In this video, we're going to review the exponent properties that we learned this unit. I'm going to go through several examples on this worksheet to remind us how to solve them. The first one we'll look at is number 1. So number 1 is v to the negative first power times 2v squared times 2v. The way to approach this problem is you want to look at like bases and add their exponents because it's all products. So in this problem, we cannot forget that if there is not an exponent written, there is like a 1. It's like having a 1 exponent written. So each of the 2's has a 1 exponent, and the v at the end has a 1 exponent. So I'm going to start with the like bases of 2. Each exponent is a 1. 1 plus 1 is 2, so I end up with 2 to the second power. For the v's, if I add the v's, negative 1 plus 2 is 1, plus another 1 would be 2. So I have v to the second power. In class, we discussed if you have a base that's to a power of 3 or less, you have to evaluate. So I'd have to evaluate 2 squared, which is 4. So I end up with 4v squared. If we look at a problem like number 2, similar setup because it's product, but 3 and 4 are not like bases, so I cannot use any properties on their exponents. So I would multiply those coefficients 3 and 4. 3 times 4 gives me 12. I do have like bases of n. Remember, there is a 1 exponent with this n that's not written. So if I add the exponents, 0 plus 1, you end up with n to the first power. There is nothing more to simplify, so that would be the final answer. So examples 3 and 4 are when you have a power raised to another power. In this case, you want to multiply the outside exponent with each of the inside exponents. Again, we have to remember that even though it's not written, there is a 1 exponent with the 4 in that problem. So I will be multiplying this outside exponent of negative 3 with each of the inside exponents. So I would get 4 to the negative third power and a to the 0 power when you multiply. We know the 0 exponent property says that anything raised to the 0 power is 1, so we don't even need to write that. I do still have 4 to the negative third power. You cannot have a negative exponent. In order to make it positive, you need to do the reciprocal. In this case, 4 to the negative third is on the top of a fraction, so if I move it to the bottom of the fraction, it would become positive. So I end up with 1 over 4 to the third power. Once you move it, the exponent becomes positive. Since it's to the third power or less, I do need to evaluate, so my final answer would be 1 over 64. 4 to the third power is 4 times 4 times 4, which is how I got 64. Number 4. Again, you multiply the outside exponent by the inside. So I'd have b to the negative third power. We cannot have a negative exponent. We need to take the reciprocal. Since right now it's on the top of a fraction, to make it positive, you move it to the bottom. So I'd end up with 1 over b to the third power. No more like bases, no negative exponents. That's our final answer. So now we go on to quotient properties. In these types of problems, you want to subtract the exponents of like bases that are on the top of the fraction or on the bottom. So if I look at number 5, again, we cannot forget about these 1 exponents that are not written. 2's are like bases, so I would subtract their exponents. First power and first power. 1 minus 1 is 0, so I'd have 2 to the 0 power. For the ends, if I subtract those exponents, negative 4 minus 2 is negative 6. So I have n to the negative 6th power. As we said in a previous example, anything to the 0 power is just 1. You can write 1 or you can just cancel it out. It's not necessary. And you cannot end a problem with a negative exponent. So you have to take the reciprocal. To make it positive, it goes to the bottom. So I'd have 1 over n to the 6th power. Now if we get to an example like number 7, same idea, you want to subtract the exponents of the like bases on the top and the bottom of the fraction. In this case, there is no other base of 3. So I would not combine that with anything. I would still have a 3. Be careful when you're subtracting negatives. 3 minus negative 1 for the exponents with the base x, minus negative really changes to addition. So that would be x to the 4th power. When I subtract the exponents for the y's, 2 minus 4 is negative 2, so I'd have y to the negative 2nd. Once again, we cannot have a negative exponent in our final answer. In order to make it positive, you want to take the reciprocal of only the base with the negative exponent. 3 does not have a negative exponent, and x to the 4th does not have a negative exponent, so those stay where they're at. The only term I'm moving is y to the negative 2nd power. So I'd have 3x to the 4th, and now on the bottom I would have y to the 2nd. If I scroll down, let's do one more. Let's look at one like number 13. So if I'm looking at number 13 right now, again, it's another product. There are no bases of 4 to combine with this one, so I would just leave the 4. I will remember to write in these 1 exponents with the r and the q here, and we add the exponents of like bases. For p's, I have negative 3 and 4. Negative 3 plus 4 for the exponents is 1. You can write to the 1st power, but you don't need to. There is only one base of q. There's nothing to combine that with, so I'd leave q to the 1st power. For the r exponents, negative 3 plus negative 2 is negative. I apologize. R has an exponent of 1. So 1 plus negative 2 would be r to the negative 1st power. There are no more like bases, but I do have to make this negative exponent positive by putting it on the bottom of a fraction. So I'd have 4 p to the 1st, q to the 1st, over r to the 1st. The only other thing I think we should review is briefly how to rewrite into radical and exponential form. So for number 25, the base always goes underneath the radical. The number on the top of the fractional exponent here is the root number. I'm sorry, I wrote that incorrectly. T is the base, which goes underneath the radical. The bottom number, in this case it's a 3, is the root number. The top number is the power. If I did the same thing for number 27, z is the base, so that goes under the root. 5, the bottom of the fractional exponent, is the root number. 8, the top, is the exponent. Now, for one like 26, 121 is the base. The root number is 2. You do not have to write the 2 because it's implied that it's already there. It's a square root. You also don't have to write the 1st power because it's implied it's already there. What we're left with is the square root of 121, which